In the final part of the lecture, we'll consider the equation of a circle. Let's have a look at the diagram. We can see we've got a point Q, X, Y at a distance r from the origin, 0, 0. We know that the square root of x minus 0 squared plus y minus 0 squared is going to equal that distance r, isn't it? Alternatively, we could write this as x squared plus y squared equals r squared. Well, there must be an infinite number of points that have this same distance r from the origin. So if we were to imagine plotting all of these points, and I can't draw an infinite number, obviously, but hopefully you can see if we put lots of points on that are the same distance r from the origin, we're going to get a familiar shape. So let's just join these dots together, and you can see that that's a circle. So in fact, what we've written here, x squared plus y squared equals r squared, is the equation of a circle with radius r centered on the origin. As a digression, you should be able to see that the circle is not a function because it's not going to pass the vertical line test. If we put a vertical line along there, it's going to cut the circle in two places, so that's not a function. Having established that x squared plus y squared equals r squared is the equation of a circle radius r centered on the origin, let's have a look at a more general case where the circle can be located anywhere in the xy plane. Imagine we take our circle that we looked at in the previous slide, centered on the origin, and we translate the center to some other point A, B. So our circle C has a center translated to the point A, B, and the image of the circle under this translation is C prime. Using the same reasoning that we had in the previous slide, that if we take the square root of x minus a all squared plus y minus b all squared, that's going to give us the distance r, isn't it? So any point P, x, y, is going to have the same distance r from the centre AB. Removing the square root as we did before, we'll have x minus a all squared plus y minus b all squared is equal to r squared. And that's our equation of the circle with a centre AB and radius r. We'll take a look at a couple of examples of using this. In the first one, we'll write down the equation of a circle with radius 5 and centre at 4, 3. Well, that's really easy, isn't it? We know that x minus a squared plus y minus b squared is equal to r squared. So all we have to do is plug in those values. The x value is going to be 4, x minus 4 squared plus y minus 3 squared is equal to 25. All done. Nice and easy, wasn't it? Let's have a look at the next example. Oh, well, I wasn't expecting that, were you? That doesn't look anything like the equation of the circle that we were working with just now. X squared plus y squared minus 6x minus 2y plus 6 is equal to 0. We've got to find the centre and radius of the circle. Well, that's a bit difficult. Should we give up on that? What do you think? Oh, hang on a minute though. Can we rewrite this some way? What about if we started by saying that x squared minus 6x plus y squared minus 2y plus 6 is equal to 0. Ah, now I get it. In the previous example, we had x minus a all squared plus y minus b all squared is equal to r squared. So what do you think would happen if we were to complete the square on the terms in x and y? Shall we give that a try? Let's have a look. We'll deal with the x terms first. So we'll have x minus 3 all squared, but we're going to get an extra 9 there, so we have to take that off, don't we? Then for the y terms, we'll have plus y minus 1 all squared, and we'll get an extra 1 which we need to take off. Plus 6 is equal to 0. So if we just rearrange those constants, we'll get x minus 3 all squared plus y minus 1 all squared is going to equal, well, that's going to equal 4, isn't it? So in fact, the radius is going to equal the root of 4, which is 2, and the centre is going to be at 3, 1. So that wasn't so bad after all, was it? Okay, have a go at the multiple choice question.